So will you teach me about static electricity?
Hi, Annika. Sure, let's talk about it. Have you ever noticed, particularly in winter, that sometimes you go to reach for a doorknob, your dog, or your best friend, and you get a small, sharp shock to your fingertips? Or that you brush your hair and it puffs out like each strand is trying to fly off your head? This is static electricity, and we're going to break it down today on Ask the Science Kid. The first thing we need to talk about is atoms. All matter is made of small particles called atoms, but atoms are made of even smaller particles, and these smaller particles are the source of all electricity, static or dynamic. This plate will represent our atom. This cup its nucleus, and these M&Ms are particles. Inside our nucleus we'll place 4 green protons and 5 blue neutrons. Neutrons have no charge. They're neutral. Protons have a positive charge. They're balanced out in our atom by electrons, which are negatively charged. We have 4 protons, so to balance them, we need 4 red electrons. For our atom to be neutrally charged, the number of protons and electrons needs to be equal. The number of neutrons is not important. Now, the number of neutrons and protons in our atom is fixed, at least for the purposes of talking about electricity. The electrons, which are freely floating around the nucleus, are much less fixed. What happens to our atom if it gains or loses an electron or two? If our atom loses an electron, it's no longer in balance. These 3 electrons balance these 3 protons, but there's an extra proton. This means the atom now has an overall positive charge. If our atom gains an electron, now these 4 protons balance out these 4 electrons, but there's an extra electron. This means the atom now has an overall negative charge. When you talk about the type of electricity that flows through wires or powers our devices, we're talking about the movement of electrons through the atoms in the wire. Static electricity is still and is caused by the buildup of negative charges because of the extra electrons. Now, normally atoms don't go around gaining and losing electrons all the time, but some materials are able to transfer electrons simply by rubbing together. When you walk around your house, you're always brushing up against things, making it possible for you to gather extra electrons. You gather electrons instead of giving them away because your body is mostly made of water, and water is a very good conductor of electricity. This means electricity moves through it very easily. We often wear shoes, however, and the rubber soles are not good conductors of electricity. This means that the electrons stay stuck to us because they can't pass through our feet into the ground. If we touch an object with a positive charge, a better conductor, or conductor attached to the ground, the extra electrical charge will zap away and continue on its journey. This is what you feel when you accidentally shock yourself or someone else. This is just like dynamic electricity, except on a much smaller scale. What about when our hair puffs up? What does that have to do with static electricity? Just like when we talk about magnets, positive and negative charges can attract and repel each other. Opposite charges attract and same charges repel. Your socks stick to the inside of your shirt after they've come out of the dryer because they've acquired opposite charges and so they're attracting. Your hair stands on end because the individual strands have acquired the same charge and so they're trying to repel each other as much as they can while still being attached to your head. You can use static electricity and this attracting and repelling of charges to do a lot of cool tricks in the lab. There are a lot of ways you can play with static electricity in the lab. I'm going to demonstrate a few of them and put a list of materials on the screen at the end so you can replicate your favorite ones. The first one is simple. Start by blowing up a balloon or have an adult help you. Start by rubbing the balloon against your hair. Next, slowly pull the balloon away from your head. Just like when you take off your winter hat, you can see that my hair is sticking to the balloon. Now that we know how to charge our balloon, we can use it for more tricks. Put some salt and pepper on a flat plate. Charge your balloon, then hover it just over the plate. The grains of salt and pepper will jump onto the balloon. You don't only have to work with balloons. For this next demonstration, I'm going to charge a plastic straw with a wool sock. Place an aluminum can on your work surface. Charge the straw, then hold it near the can. This one is subtle, but you can see the can try to roll towards the straw. For the final one, start by tying a string around the neck of the balloon. Charge your balloon, then hold it by the string so it can move freely. Wait until it comes to a rest, and then hold a metal spoon near it. The balloon will be attracted to the spoon or even stick to it like a magnet. There are many different tricks and demonstrations you can do with static electricity. I did just a few. You might even be able to think of some yourself. Here's a list of the materials I used. The last thing to talk about with static electricity is why it always seems to be worse in the winter. You're not imagining things. We really do experience more shocks and clings when it's cold out. That's because cold air can't hold as much moisture as warm air. Remember that water is a really good conductor. So when the air has a lot of moisture in it, excess electrons clinging to our bodies can dissipate into the water and the air. This means that there are fewer electrons hanging around us ready to discharge. During winter, however, when the air is drier, we hang on to more of those electrons, leading to bigger buildups of static charge, just waiting to zap us when we least expect it. Does make taking off your winter hats fun, though. Thanks for sending in your question, Annika. I hope you'll feel more informed about static electricity. If you have a question you would like answered or a suggestion for a future video, send it to AskTheScienceKid@gmail.com and make sure to subscribe to Ask the Science Kid for more fun facts and answers to kids' science questions.